Alright, I hope I am live and I hope the voice is audible. So, good morning, everybody. This is a stream that I'm doing after a very long time. So, today we are solving a few gate problems. Right, let me just pop out the chart. Right, yep, and it is very okay. I'm not supposed to close this thing. Yeah, that checks out. So I just wanted to solve the 2025 gate paper with help absolutely. Obviously, I mean, I'm not doing without any like all from my brain. I'm not trying to do that, but I'll just try to solve the problems with AI and all, and with as many resources as I can use. That's not notepad. My bad. Okay, I'm supposed to close this thing, dude. Yeah, I hope none of my viewers are educated enough to know what an API key is. Alright. Uh, okay. Okay, let's take a new sheet. 2025 gate. What's that called again? It's called set one. Yeah. What? For some reason, one mode's not responding. Yeah. Yep, set one. How about we do, something like this? Here and this, right? So Ravi had a younger brother. Okay, my mind's out of hearing this. Dude, what's happening with one mod? Yeah. So okay, something happening. All right, I'll put this like this. Okay. We don't know the about the younger brother, so it is going to be a younger brother who had thought at. So use a university, even though it is a vowel, it makes a consonant sound. It's not like umbrella, right? Umbrella is also you, but it makes if you know Telugu, it makes this sound, but it makes this sound. So both are different, and at I University, he is widely regarded as an honorable man. See, and again here, even though H is a consonant, H is silent, so the first letter that we are pronouncing is O. O is a vowel, so it's like honorable, honorable, something like that. We don't know, like one of many honorable men, so it is A, and N. If I'm not wrong, 58 is the answer. Yeah, A, and N. That's good. I think we had good enough explanation. By the way, this site's name is called Gate Overflow, and it is a good site for solving gate previous year questions and gate questions in general. They have a wide community as well. So the CEO's decision to downsize the workforce was considered myopic because it sacrificed long-term stability to accumulate short-term gains. Even if you don't know the word myopic, you can see here. It sacrifices long-term stability. Just to get some short-term gains, you are not thinking long-term. So visionary is kind of opposite. Visionary is a person who thinks long-term. So that's not it. And he asked for the synonym, not the antonym. So short-sighted. Actually, it is a if you have studied 10th class physics, there are two common things like myopia and hypermetropia. Right, myopia is called short-sightedness, and hypermetropia is called long-sightedness. And for one type of these things, you use a concave lens, and for other type, you use convex lens. Like this is eye, you have a retina, and in front of that, you put another lens. There will be focal point, something like that. I mean, I'm saying all of this because we have learned about myopia. So short-sighted is the answer. Yeah, short-sighted is the answer. What's the third one? The average marks obtained in a class in an examination was calculated as 30.8. So 30.8 it is. While checking marks entered, the teacher found that the marks of one student entered incorrectly as 24. So the entered marks were 24 instead of 42. After correcting the marks, the average became 31.4. How many students does the class have? Alright. So how do we even approach this question? We know the formula for average, sum of observations by number of observations. That came out to be as 30.8. So we don't know the number of observations. So what we know is uh, something 24 plus xn by n. Let's say there are x things over there. That gave 30.8. So 24. So you corrected this as 24 instead of 42. So how much was added? 34, 40, 18. 18 was added, right? Alright. I need to look at the answer. Let there be n students and okay, you cannot. Let there be n students and total of all students except that one student whose marks are wrong by x. Okay. Instead of taking these in all variables, we don't even need these in the first place. So x plus 24 by n is equals to 30.8. Yep, that makes sense. So you need to get what x is. 30.8 times n, yep, minus 24. That's it. Right, 30.8 n minus 24. This is equation 1. So after correcting, x plus 24 was replaced by 42 is equals to 30.8. Yep, that's the trick. You don't need all of these n things because you cannot solve it as a linear equation if you thought about all of that. The remaining sum is going to be same. So what it became 31.4. Yeah. Because there is only one value that you need to focus on, just limit it to one variable. So these are the two equations that we need to solve now. And how do we solve this? Oh god. Oh god. We were given options, I think. Solving by options is easy. Okay, whatever. Let's multiply by 10, 308 minus. Does the ratio remain same? Yeah, you can do that. You can do that. So, how much this will be if you subtract it? This will be minus 6n, and it will be plus, right? 240, 340, 420 plus 180. Yeah, that makes sense. So minus 6n is equal to minus 180, n is equal to 180 by 6, that's 30. There are 30 students in the class. We solved it. Wow. Okay. Anybody's in the chat? Nobody. So we solved 3 questions and okay, firstly, these are aptitude questions, that's why they are taking less time. If there were some other questions other than aptitude, they would have taken a lot of time. So relationship among P, Q, R, S, and T. P is brother of Q. S is daughter of Q. Daughter of Q. T is sister of S. Right, siblings, daughter, sister. R is mother of Q. Mother of Q. Okay. R is grandmother of S. One is true. P is uncle of S and T. Yep, that's uncle. Uncle true. R has only one son. No, but these two are right. That's false. At minimum two, right? Two children. Q has only one daughter. Right? No. Right. T is the sister of S. Girl and girl. So Q has only one daughter. That's false as well. Both 1 and 2 are true. 14 is yeah, if I'm not wrong. Oh, nice. Nice. What? Option E is correct. Nice, we did it, man. We did it. Okay. I mean, the thing is, I have kind of solved these questions before. That's why, they are going in much faster pace. If that's not the case, they would have taken some more time, but still, we are able to do them. Okay, a map is given. Spatial aptitude. The library is located in the northwest of Canteen. So northwest is something like this. Library. Canteen. Where is canteen? Canteen is actually located west. Sorry, I mean library is located to the west of Canteen. A is false. The hospital is located to the east of chemistry lab. Chemistry lab, hospital, that is not. That is also false. Chemistry lab is located southeast of physics lab. Physics lab, southeast. Chemistry lab, C is true. The classrooms and canteen are next to each other. Classroom and canteen, they are not next to each other unless it is a circular map, which is not. So C is only correct. Option C is the correct choice. ये क्या लिखा क्वेश्चन में ये भी लिख दिया था कि सी might be the answer इतना दिया था तो okay. I mean, they should have solved that theory of computation question. I have put a brown paper in my pocket along with the chalks and possibly other things. I suppose everyone must have reflected how primeval and how poetic are the things that one carries in one's pocket. The pocket knife, for instance, the type of all human tools that invent of the sword. Once I planned to write a book of poems entirely about the things in my pocket, but I found it would be too long. And the age of the great epics is past, and the age of the great epics is past. Piece of chalk, okay? Based on the information provided in the above passage, the following statement is true. The author of the passage carries a mirror in his pocket to reflect upon his things. No, he never told he wanted to reflect, but that's not mirror. The author of the passage had decided to write poems on epics. No. If he wrote to write a poem on the pocket of his things, it would become too big, and it's not the time of epics. That's false as well. The pocket knife is described as in front of the spot. That is correct. That is correct. Epics are described as too inconvenient to write. Actually, even if you can conclude from this, you should not take that into consideration because as age of the great epics is past, just because something is past doesn't mean it is too inconvenient. So don't think too much. Just say is the answer. Right. Okay. Okay. He had made the valid inference as we did. Right. We told the same. We had the same discussion, dude. That's good. So that means we are thinking in the right direction. Anybody's here? Nobody's here. All right. Okay, this is on 9th class level math, and we are bad at that. QR and ST are parallel to each other. That's good. The shortest distance between these two lines is how the shortest distance between point P and line QR. The shortest distance between these two lines is perpendicular, absolutely. Half the shortest distance P and QR. So this distance and this distance is same. Angle PST2 repeats GMS QRT. Area we are sorry, we don't know the formula for area of trapezium. So alright, and again I have solved this question before, so I kind of remember what's going on over here. So these two lines are parallel. That's what we are said. PST and QR. Let's draw something like this. This is perpendicular. So at this point of intersection VO, and let this be A. PY is equals to A. We were given that. And so triangle PST by quadrilateral STQR is equals to question mark. Okay. So what do we need to do to get this area? To get this area, we can do something like this, right? Triangle PQR minus triangle PST. We can do something like that. All right. How do we do that? How do we do that? Right. Angle PBS is equal to angle PAQ. That's good. Pair of corresponding angles. According to question, BA is equal to half PA. Perpendicular distance is shortest. Okay. We got it. So PA is equal to half. Sorry. I mean PO is equal to half PA. That's good. So now we need to prove for or do you say that? No, that's not congruent. Similar, yeah, similar. All right. PST and PQR angle. Yes, wait. Okay, this is a common angle. Common angle that checks out PST, PQR corresponding angles. Okay, that's all you need. Yeah, that's all you need. Two angles enough for similarity. Okay. For similar. So those triangles are similar. Absolutely, we proved that one. And now we have only one formula for area of triangle. That is Heron's formula, but that is out of context right now. Half into what is the base? The base is ST, and what is the height? Height is P. And what is the bigger triangle? What is the base? Base is QR, and what is the height? That is PA. Right. Since we are asking the ratios anyway, we know the PO is equals to half of PA. So this is 1 by 4 of ST. And this is no. This is 1 by 2 into ST into PO is half of PA. Right. Okay. QR. ST and QR. Do you have any relation between ST and QR? Yeah, good. Since it is that's the point of similar, right? 1 by 2 into QR. 2 times ST is equals to QR. Point of similarity. ST is equals to half QR. So substitute it over here. Or do something. 2ST into PA. 2 cut off ST into PA. This is 1 by 4 ST PA. So the bigger triangle is 4 times. Smallest to big is equals to 4. So the smallest to big is 1 is to 4. So trapezium, this is 4, this is 1. So this will be 3. Right? So 1 is to 3 is the answer. We got it. We got it. Yeah, only if we did the 9th class math problem, we would have gotten that. So 6 face die. That's good. Roll thrice. What is the probability of 6 rolling? Exactly once. So 6 exactly once is like how can you do this? Exactly once. Right? So not twice, not thrice. 1/6, first iteration. Okay, we need to build it properly. Not 6 is equals to 5/6, right? Okay, so first row only. That means he got a 6 and okay, he got a 6 in first row and not 6 in second row and not 6 in third row. That's good. 25 by 36 times x. What is that? 216. Second row only. That's again 25 by 216. And third also 25 by 216. Any one of these can happen. So that's 75 by 216. Yeah, that's good. Okay. Binomial distribution. I mean, once we cover, the probability and the statistics, we might get an idea of what's going on here even better. Okay. Paper foldings. We need to do a lot of practice for this paper foldings. So this will be folded like this. So this is folded like this. Okay. This is the longest side. Is that? No, I cannot figure out. It was folded like this. So this will be, the perpendicular angle. So this is this angle, right? Okay, spatial attention. Okay, he wrote something. To get something in center, you need to cut at the left corner of the triangle, right? No, cut at the corner of the triangle. The question is, isn't it? Triangle shaped cut is touching the edge of sheet C. What? Okay. So this is this. Wow. Yeah, we got this one right. Okay, this is the first time we are using AI. Test symmetry, fold order, and benchmark propagation of unfold. Each fold among line of symmetry. Identify folders in order. Track the punch location. Mark the punch point related to nearest. Top right quadrant. Take heuristics. So we need this. This checks out. Yeah, that checks out. Okay, nothing at the center, so nothing will be found at center. That's good. Full symmetry is mismatch. Okay, this one, if you dude. This one, if you unwrap it and roll. I understood the D option though. Yeah, I understood that one. And what else was written? A triangle shape requires stretching edge as a shade on the tip. How will you understand that? Okay, I will track this. I will track this. Let's get a snipping tool. So this is a folder like this. Oh, I just cannot visualize it, dude. Okay, this is folded. And if it will become even smaller. Right. Dude, that is a folded edge, that's for sure. If you fold it like this angle became this angle. Okay. Okay. This was folded like this and it was kind of made it straight. So I assume this is a folded edge. If you unfold it, alright. This angle is corresponding to this angle over here, if I'm not wrong. So a fold punch was here, so it will form something like this. And if you get it out, there will be two things like this. Okay. And here there is a rectangle. I don't know man. Okay, there will be two rectangles. That's good. Not alright. I think I'm making more analysis for this one. We need more spatial geometry. Spatial aptitude. We need more of that, that's for sure. We need more spatial aptitude. For distinct flavor ice cream, one can purchase any number of scoops of any flavor. The order in which the scoop of purchase is inconsequential. If one wants to purchase 3 scoops of ice cream, how many ways can he make the purchase? Okay, so is it a permutation or combination? Combination. It is. No order matters, right? Just selecting out of 4, you can select how many? 3. That is 4 factorial by 3 factorial into 4 minus 3, that is 1. That is 4s. A is the answer. A is the okay. This point we missed out. Any number of scoops of any flavor. We missed that one out. Stars and bars. Right. Okay, let's do this for this 3. How many we got for the first one? Out of the 4, you can choose for 3. Okay, this is the approach that I am thinking. Four, three, one. Okay. Four, three, two is all right. How much is this? This is 4 plus this will be 4 into 3. That's 2 into we cut off, and that will be 2 times plus 6 plus 4. Okay, that's messed up. That's 14 only. That's 14 only. Why is why is 47 plus 4 zeta plus 4 zeta is not working in how I go in this question? Counting distributions versus choosing boxes. And subsets. Ways to choose non-empty subsets of boxes. At most one item per box. There are some configurations where you choosing box. Choosing boxes get the number. Any range with to example voting. Is not working in the case of the science screen question. And what exactly are we counting? Ice cream distribution, okay. Count subsets of boxes chosen from 4. The sizes of 1 to 1 implicit assumption each chosen box get exactly 1 ice cream and unchosen box get none. You have at most 1 ice cream per box. This message is like 2 scoops in this flavor. Okay. Yeah, got it. So you see, this counts what? Let's say we got red, blue, green, and yellow flavors of ice creams, and I need to stack 3. So it chooses red, blue, green, and it chooses red, blue, yellow, and it chooses blue, green, yellow. Now, what? 4 distinct flavors, alright. Red, blue, green, red, blue, yellow, red, green, and yellow, yeah. That's all it chooses. It doesn't choose anything. But we can choose red, 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 blue, 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 red, blue, blue. All of this. Okay, got it. Stars and bars counts distributions of identical items with the distant boxes with unlimited capacity. That's good. N plus k minus. Let's say we got RBGY has flavors. The first approach chooses only RBG, RBY, BGY, and RGY as valid combinations that we can choose RR, RBB, RRB, etc. too. Let's see how how better it understands context. Okay. Okay, I don't think it is holding the context of previous question, but that's all right. So stars and bars. I have, so all this one for our like semester as well. Let's see. There is stars and bars. N plus r minus 1 by r. So here 6 say how many? Let's try 6 3 and 6 4. Is the same result or what? Let's say if we do something like 6 3, so that is 6 factorial by 3 factorial times 3 factorial. Okay, that is 6 into 5 into 4 by 3 into 2. This is 20. Alright. Kind of understood that one. Okay. General aptitude. We solved the 10 questions of general aptitude and good. We got it, man. We came to the theory questions in 47 minutes. Okay. We are supposed to increase the speed, but since this is our first step, that is alright. We are in the learning phase. The program is running on a non-vibrant single processor computer system. The computer is connected to an external device that can interrupt the processor asynchronously. The processor needs to execute the interrupt for the there is this interrupt. Okay. Explain this question. I assuming don't have any prerequisites. Explain every term. Explain every technical. And the question too. This prompt should work out for any question that we are having a problem with. Whenever interrupt comes, processor will complete execution of current instruction pass and saves the current. No. We have changed the question. Does it remember context? I don't know. But I will check it out now. No, it doesn't remember the context. Yeah, it is very bad at remembering context. Alright. And something unexpected happens, like a keyword. Press a timer alarm, the processor gets an interrupt. In what order does the processor handle the interrupt? Interrupt service routine. So a basic version of ISR is given. Interrupt service routing. Here's the program. Saves program to basic. Program counter. Loads the basic with an address of ISR. Loads ISR. That's enough. Finish the instruction currently being executed. A processor instruction interrupt program counter register that stores the address of the next instruction interrupt service routine. Finishes the current instruction. Load these its ISR address. This is mostly a theory question, right? The processor finishes the present instruction, that is array, and the processor has the content on the program counter. The program counter is loaded with the start address of the ISR. Option D. Whenever interrupt comes, processor will complete execution of the current instruction first, then it will save the current PC value so that it can return to the program after serving the interrupt. Then it will load the start address of the ISR in PC and serve the interrupt. Okay. So let's say this is basic. This is processor, right? So what will it do? An interrupt is coming. Interrupt is coming. So complete. First step is complete. Whatever it is doing. Saves in basic. Saves the PC value because it need to come back. Something is, we are in the middle of something. So it serves the interrupt and resumes it. That makes sense. The processor is the content of the program counter. Before saving, okay, the program counter is loaded with the address of the ISR. Okay. Let's say this is a stack or something. It contains ISR and it contains current. I don't know if you can see that or not. Okay, this is 3 and this is 1. This is 2. That's good. So basic question on ISR. Kind of build which of the following statement is false regarding the symbol table. Symbol table is responsible for keeping track of the scope of variables. Symbol table can be implemented in binary search. Let's give it the tab and let's finish this. Let's see if we got. The question is about compilers, and the compiler is a program that translates human readable code, like the Java information code, that a computer can run. The particular word is asking about parsing. The question, the process where a compiler checks the structure of a program, like grammar. Compiler, translator, parsing, like checking grammar in English. Grammar, set of rules. Okay. The top-down parsing. Segment. Bottom of parsing. Left recursion. A grammar rule that refers itself at the beginning. Alright. The ambiguity. Okay. Which grammar can be paused? Is that even the question? I don't think the question is about top down or bottom of parsing. It is about the purpose of symbol table. So tell me what a symbol table is, where it is used, what are its functionalities, and all. A symbol table. Okay, tracks the names. Things like variables, functions, clauses, constants. Compiler headers book. During compilation, it is used in almost lexical analysis. Identifier is found in it's entered into the table. Semantic analysis and compiler checks the table names. Types match code generation. And example each variable lives in memory. Scope. Okay. So for each symbol it stores the scope because scope is important. Okay, type size, scope, insertion, lookup, deletion mode. Okay. It doesn't even read the question. How is this a compilation? Okay, can you read this question? This is that question. Explain on the 7 is of what is it? 7 phases of compiler. Lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation. What else are there? Let's see. There are only 6 phases. Okay, let's see. Yeah, we are learning more than what is required for this question. Lexical analysis. Tokens. Tokenization. Okay. Syntax analysis. Example, a semicolon. Semantic analysis. Logical correctness. Adding the entire Boolean intermediate code generation. Code optimization. Something like that. And code generation. Assembly or binary. We do not know assembly. Information. So those are the 6 steps of compiler. So scope of the variable that is responsible. That's good. So a symbol table can be implemented using binary search tree. To ensure fast lookups of login and overflow, it is implemented using yeah. A symbol table can be implemented using BST. It is just a knowledge thing. It is required in all the 7 phases. That's good. Which one of the following techniques used in compiler code optimization is live variable analysis? This is a main theory question. Code optimization. We saw that. Well, that's 5th step, yes. Okay, we are supposed to know. rationalize this question without assuming any prerequisites. How about that? So, which compiler optimization technique uses variable analysis? First, what is live variable analysis? Variable, okay, live variable. Here x is live after being assigned because, okay, if variable value is not used again, it is not live. That's good. Why do compilers care? Computers have a limited number of registers. If a variable is live, it should stay in the register. If it is not live, the register can be freed. That's good. Now the options are explained. Runtime function call management. About handling function call. Which one of the following techniques used? Register assignment. Strength reduction. Constant folding. Alright. This is again, I think it is one more question. Use it for register allocation. Nice, man. Variable. Variable. Which needs to be used in later sections of code as well. How about that? Decides whether decides whether variable should store, decides whether variable should stay in register or not. Alright. So it is strength reduction, constant folding. Since there are options, it is important. Strength reduction is I plus, my bad, I plus I can be I times 2. So 2 plus 2 to 4. This is constant folding. And what is this one? Runtime function call management. It had nothing to do with variables. It was told. It got everything to do with stacks, frames, and parameters. Yeah. All right. Where are we? Here. 3 questions were done. Demand paging memory management system with 32-bit logical address, 20-bit physical address, and page size of 48 bits, assuming that the memory is byte addressable. What is the maximum number of entries in the page table? Whatever, alright. mention this tab and explain this question. Explain this question without assuming any prerequisites. In a computer system, these demand paging, memory management technique, logical address, physical address, everything's given, memorized by address. Each address points to a single byte. Logical address, the address generated by your program. Physical address, page table, byte address. With 32 bits, the program can generate 2 power 32 addresses. That is the total virtual memory size. Given page size is 2048. So each page okay. Physical address. Each page table needs one entry in the page table. Let's see the analogy. 2 power 32 books. Logical addresses. Each shelf can hold 2 power 11 books. Yeah, that's my question exactly. Why give physical address? And you told memory is byte addressable. If that's not the case, what will have happened? Logical address is 32 bits. How big the virtual memory space is? Physical address. Okay. Maximum. The 32 words. Each house number points to one room or apartment of 4 rooms. Okay, that's good. So let's try to answer this one. 32-bit logical address. So you can think of like this. The address looks something like this. 32. So 2 power 32 combinations are possible because obviously it can mode either 0 or 1. That's why 20-bit again 2 power 20 is possible. So page size. So this is assume this is memory, and memory is divided into blocks. So each block is 204 bytes. So that's like 2 power 11 bytes. So now maximum number of entries. Table. Page table is memory. I think this is memory. This is page table. Stores entries, right? This is called page table. How many entries are needed? Okay. There are 2 power 32 logical addresses and byte addressable. So 2 power 32 by 2 power 11. That's it. That is 2 power 21. That's the answer. Is that or something? Alright. Maybe an offset. Okay, we saw something. Offset. 2 power 21 entries. We are expecting okay. Page C, this is a page number. Page offset. How did you calculate the offset? What about physical address? Size of the physical memory. Frame number. Correct brain, alright. I need to look at that one out. Okay. A schedule of a database transaction. Hey, this is database. We studied this one for 2 days. OS अगर बता रहे okay, I have a little problem bro studying right reading Hindi. OS अगर बता रहेंगे तो easily solve हो जाता ये वाला संपर्क ना कौन सा याद नहीं आता. Same for oh, that's true. Concept. So maybe I can simultaneously. So 3 transactions. Read and write, okay. So let's draw the what do you call the table. T1, T2, T3, R1X, W1, Y, R2X, R2, Y, R3, 3y about t1. Oh, which other transactions will be the transaction di about at the end? Okay, which other transactions will be required to roll back? So it is aborting. So which other transactions needed to be rolled back? So it wrote some value, updated while it got cancelled, right? Whatever it read y. So R2 and R3 needed to be rolled back. T2 and T3. Yeah. Since as W1y read by both T2 and T3, it commits about T1 required to roll back both T2 and T3. Wow. Wow. I solved a database question. Wow, I mean, okay. Wow, I solved a question. Identify the correct matching between the OSI layers and the corresponding functionalities. OSI open source interconnection. Right. Okay. This should be an easy one. So it has 7 layers, right? Explain all the layers with the functionalities, please. Network layer, transport layer. Okay. OSI open source interconnection is like a blueprint that explains how data travels from one computer to another across a network. It has 7 layers. It is a specific job. Think of it like a postal system. I need the general explanation for 7 layers, please. Okay. Data travels from one computer to another. Physical layer deals with actual hardware. Okay. Data link layer packages bits into frames and serves reduction and correction and ensures reliable delivery between two directly connected devices. Decides the path. Network layer routing. Transport layer end-to-end communication. Okay, so data link layer. Network layer is responsible for packet routing, framing, and error language. Data link layer. So that's the answer. Yeah. Transport. Manager sessions. Presentation layer. All right. Let's write it at this moment. So Shall we go up? Yeah, we shall go up. Now what? Right. Continuation. Yo. View. They should work out. Yep. Open source interconnection. What? OSI. Open system interconnection. Okay. So what do we got? We got a physical layer. Physical layer hardware. Cables, switches. Data layer. Error detection and correction. I really love the analogy. Checking for damaged envelopes before traveling. Damaged. Before crossing, alright. And what is the third one? The third one's network layer. Data mining path. Okay. Packet routing. That's routing. And then transport layer. End-to-end communication. IP, IP is the king of network layer. Example, TCP, Transmission Control Protocol, UDP, the full form of UDP. Analogy, ensure inquiry reached. And session and presentation layers. Session layer. No, there are 7, right? Session, presentation, and application layers. So, very understandable way. Readable way. session. Making sure session persists. Application layer. Email, website, file transfer. Oh yeah, FTP. There is FTP as well, file transfer protocol. This question we have started more than enough for this one. Okay. We are back at recurrent relations. Ouch. Or is this one? Surjective functions or onto functions. There is a flag. I don't know. Yeah, let's get a new set. Okay. A function is a rule that takes input from one set and gives exactly one output from another set. Onto. If every element is in the target set, it gets by at least one input. If every element in the target set. Okay. Codomain is equals to range. Right. For some reason, it is having a loose connection. Right. Let's check it out. Yep. That checks out. F of F and F of G are onto. So codomain is equals to range. G must be what? That is our question now. Okay, how do you even approach this question? Okay, composite function. We onto function, whereas need not to be on or one. Is neither on one nor on the first function. If composition of two functions is on one, then first function applied must be on one. The second function applied maybe or may not be. This seems good. The second function bijection, then the first function must be on the. I have read this one before. So let's see. So if this is 1 1, right? Let's say f of g of x. Let's say this is not. Let's say this is not 1 1. Then he is saying this cannot be 1 1 2. 1 2 and 3. Yeah. So if you do f of g of x, this one, right? So since this is not 1 1, then this cannot be 1 1. That makes sense. And if this is not on 2, the second one is not on 2, then f of g of x is not on 2. Yep. That makes a lot of sense. 1 1 is dependent on 9. One is domain dependent. On 2 is range dependent. Dude, this is eating me. This is range dependent. So, what is he saying now? If this is g of x must be on 2, then only it will be true. Mm. What's the answer? Okay. Huh? Now what? There is some sort of ambiguity. G is a function. G is a function from A to B. F is a function from B to C. there is something wrong with this question, it seems, and it is hallucinating. The copilot is hallucinating. So this is A to B, and this is F, and this is okay, G, sorry, and this is F. F of J of theta is defined as this. So G is the first function. For this to be onto, F must be onto. That's it. No need of G. No need to do anything about G because G is first. First quantum function. Composition is defined as F of J of theta. F of okay, got it. You have to say is composite function. B those is not okay, this is to be onto. Okay. Yep, there is an ambiguity over here. Okay, which one? This one. Let G be an undirected graph with positive edge weights. Undirected graph, okay, with positive edge weights, and T is a minimum spanning tree of G for any two that is U and V. Shortest distance between U and V, J and T respectively. Undirected graph. Minimum spanning tree G, okay. So consider some sort of graph like this. 1, 2, 3. 1, 1, 2. Then the minimum spanning tree will be something like this, right? One, and 2, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That works out. So what he is asking, and D U to V is the shortest distance between U and V in G and T respectively. Let's do the shortest distance. This edge is not covered. No, that is not necessary to be the case. But if you do this as 1, then still it will be a minimum spanning tree. So this is not the case. This is not the case. G of U B. So D1 is what? D1 is G. So this will be smaller. This may be smaller. Yeah, I think B is the answer. And Misty may or may not be the shortest path. Okay. Whenever there is only one option correct, I'm only given options. For example, is sufficient identify answer provided that it will give only one option is correct. Okay. Yeah, MST. Bro, like no, drop here. I mean, the single statement is enough. Okay, I need to log in. Let's log in. Testimonials. Air 130. Air 40. Okay, dude. So where are we? It's all almost 18 questions. Like 1 hour 48 minutes. This thing lagged. Can anybody see me? What about my camera? Hello? Okay.